Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Rocky Lhotka. Rocky is an open source and distributed systems architect, author, and speaker. He's currently CTO at Cognizant. I'll get it in a second. Cognizant Soft Vision, and calls Eden Prairie, Minnesota home. Welcome, Rocky.
Glad to be here.
Yeah, so before we sort of jump into the meat of things, would you give our listeners a little introduction to yourself? Perhaps tell them how you got started in the industry.
Sure. I got started, I grew up in the middle of Minnesota, so surrounded by hundreds of acres of forest and no real access to computers. This was back in the 70s and 80s. And, but I fell in love with just the use of computers, what little I had access to. We started with a mainframe that we had a 110 dial-up modem with a rotary phone, and then got Apple integer computers and Apple II computers. And but I think a lot of it is that, even though I grew up in the country, we were always problem solving. We were, I get that both from both parents, really. My dad bought Heathkit projects, like depth finders to find fish, and we were always, just solving problems, mechanical or otherwise. And software uses all those same skills, and so, that's how I got my start, anyway.
Okay. So sort of what brought you to what you're doing these days?
Well, I followed largely, I suppose, a traditional, or what is now traditional. I got a computer science degree and didn't actually exercise computer science as much as went into business software development. Which shouldn't discourage people from computer science. I don't mean to do that, but so much, especially back then, so much of the focus in computer science was on how to design and build programming languages, and how to build assemblers, and how to interact with hardware in an optimal way. And very, very little, in fact, pretty much nothing that is at all relevant to business software development. But of course, the job market, largely focuses on business software development, not on building compilers. So, I think, like most people, I ended up doing, business software, which it's not like the computer science was not useful, because it has been immensely useful, but it's certainly not what I had in my head when I was going and, taking all those classes in college.
Yeah, and someone needs to use those compilers, right?
Yeah, well, and of course now over the years, I've spent a lot of time interacting with a lot of folks at Microsoft, for 20, 30 years. And so I'm friends with people that either are or have been authors of the Visual Basic compiler and the C# compiler. And I at one point got to hang out with a guy that was at the time the architect for the Micro Focus COBOL compiler. And I was kind of chuckling, because I'm like, really? It's like he was a young guy. And this was, I want to say in 2005 or something. And he was in his late 20s, I would say. And I'm like, wow, how did a guy without gray hair become the architect of the COBOL compiler? and he's like, well, how many people in the planet get to be architects for a compiler, period? Mm. And I'm like, oh yeah. So I mean, for him, this was like a dream job, right?
Yeah. So what's it like? What's CTO of Cognizant Soft Vision? What's that like from a day-to-day perspective?
Yeah, well, I'm not entirely sure yet. I spent the last 10 years being the CTO at a consulting company called Magenic. And we grew to 850 consultants roughly. And we were recently acquired by Cognizant Soft Vision. And so definitely a lot of changes because, Cognizant is a 300,000 person global company, and Soft Vision is a subsidiary that's about 4,000 people. So that's not so intimidating. But I'm used to working for a company that has less than 1,000 consultants, and so it's definitely a change. Okay. But I would say so far it's been good. It's been interesting. I've spent my entire career directly working for small companies, but I've worked as a consultant for some very, very large companies. It's a little different to be directly employed by a very large company, right?
Yes.
But that said, you have a fair amount of experience in open source software as well. Is that correct?
Absolutely. Yeah, I've been directly contributing to open source for 24 years, almost 25. And it's been an interesting journey because if you look back to the mid 90s when I got started, open source as a concept was just starting to come into the public consciousness. And at that point in time, most things were called freeware or shareware. And those words still exist a little bit, but the idea of open source and the idea of copyleft and GPL was as much a joke at the time as it was anything real. And of course, now it's not so much of a joke anymore, is it? Right? This is all very real and impacts people, from individuals. Like right now, at least I'm recording some of this using Audacity, which is open source, and but all the way up to massive multi-million or multi-billion-dollar software projects that are based on open source software that somebody somewhere wrote and just contributed to the world. And that's pretty amazing to think about.
Yeah, I mean, I'm on Windows and I program with Windows technology, but even 90% of the software I use is open source. I mean, the language is open source. The editor, Visual Studio Code, is open source. The WSL, so like Linux distributions are open source. I mean, so much of the software that I use is open source. So I don't know. I'm curious what the world would look like if open source hadn't become a thing. Would we still be stuck in the 90s, or would we have been able to progress to where we are now if open source hadn't been a thing, or would everybody be on AOL downloading wares?
It's hard to say because there's competition between companies that certainly drives a lot. And so today Apple spent a bunch of time telling everybody what they're all about, their new iOS and Mac, and language enhancements and all sorts of cool stuff. And they are very much the Microsoft of the 90s, right? They're very closed, very secretive, and a lot like what Microsoft was in the mid 90s. And yet they're still a driving force for enhancement and progression in our industry, because they're competing with open source, with Microsoft, with Google, so I think you're right in some sense, because open source allows people to take some really innovative ideas and run with them in a way that probably would never get funded by a corporate entity. And sometimes those ideas are victorious on their own. Sometimes a company buys out the idea, buys out the open source project. And sometimes, the innovation is driven from proprietary companies. And so I think it's a combination of all of these things.
Yeah, it seems like there's a big discussion about open source software sustainability, corporate sponsorship, or how to make sure that these projects stay afloat, that the maintainers, the contributors are maintaining the software, so to speak, that there is a community around it. Has that changed much in decades? Is that sustainability model changing? Is there a new horizon coming, or like what is the future of sustainable open source software in your opinion?
It is tough, and it's a complicated topic, although I don't think it should be complicated. And you're right. Just in the last week or so, there's been a lot of activity because of a blog post and some tweets around it that have generated a lot of great conversation. About a month ago, well, actually a little more, I guess 2 or 3 months ago, I published something for Forbes that was along a similar line, responsible use of open source, and what that should mean, which isn't what it really means, right? But what it should mean, in my view, is that there's an unwritten contract with open source, and that if you use open source, you are beholden to the same community. Your fate becomes tied to the creators of open source. And this is especially true if you're relying on open source frameworks or open source tools or open source operating systems to do your enterprise work. It's not quite so true if you use an open source tool to create a graphic, and once you're done, now you've got the graphic, and the tool goes away. It might not be the end of the world. But if you're using something like my CSLA.net to build your enterprise software, and CSLA goes away, then you can't maintain your software anymore. Well, I mean, you can because it's open source, but now you have assumed the ownership of the entire thing. And that's true for relational database engines and operating, right? I mean, all these things that go very, very deep. And it's like, well, open source is better because I have the source. I'm like, well, that's true only to the extent that you can employ people that can actually maintain the source. I can't maintain Linux, right? I gave that opportunity, like we were just talking about at the beginning of my career. I could have gone down that path, but I didn't. And so here we are, decades later, and I'm like, yeah, I would have to start over to become an operating system, developer architect or a database engine architect, or and most companies that use let's say an open source database are users. They're not, their developers are not database architects. So yeah, the responsible participation in the ecosystem is key, and that might be contributing back. It might be just contributing via money. Those are all good, but if you don't contribute at all, and I don't mean, where it gets complicated is, I'm not necessarily talking about you as a developer. I'm more talking about you as a business, right? Because most of us work for a company, and the company pays us to write something, and then we choose to use an open source framework or an open source tool. But that's really, like I might choose that as a developer, but the burden is more on my employer than it is on me. And so really I need to make sure that my employer understands that we are using this open source thing, and that in order for it to have longevity, because enterprise software, we're talking a 10 to 20 year support horizon, right, for most of it. And so is this framework going to exist for the next 15 to 20 years? And the answer is a shrug. Like, who knows, right? And so I'm writing a $10 million piece of software on top of this thing. Maybe my employer ought to contribute to in some way to make it viable for that open source framework to exist for the next 15 to 20 years.
Yeah. So how much investment is required by the community to prevent the dome from collapsing and everything falling to the ground in a mash of software projects that can no longer work.
Right. Well, and I mean, a key example of that is that JavaScript, was it LPAD? This was years ago, but it was an NPM package that's at the base of an awful lot of the web. And the developer got frustrated and yanked it. And it was a disaster. It was in the news. I mean, it was like the mainstream news. This was big, right? And part of the fault was certainly on the package manager for actually even allowing the concept of yanking a package. You know, but it still goes to show the vulnerability that pretty much the entire industry has at this point to major open source projects, or even really important minor ones, going away.
So, what do we? I mean, obviously, if you're pulling in something that's closed source, that's costing the business money, it's a lot easier for the business to be aware of that, because, like, me as a developer, I'm not going to be paying the licensing fee, right? I'm gonna have to go get someone to go handle that, and then I think that also allows for the business to sort of be a little bit more involved and cognizant of when we're pulling in those dependencies. But pulling in an open source package is just super simple from a developer's perspective. So like that we can add in that dependency at almost no cost, but there's a hidden burden. What is the, from a developer perspective, what really ought I to be bringing back to the business, and you know, how does that relationship sort of work on a really good level?
You're right about proprietary software in that companies, yeah, for one thing, yeah, you're right. The developer doesn't pay for it; the company does, which is good, right? Because now it becomes the company's choice, and a company that has any experience in this will do some level of vendor assessment, right? You know, not just assessing does the product do what I need it to do, but also they'll look at the company that provides that product and look at its financial health and history and make an assessment and say, oh yeah, you know, they've been, like, Microsoft seems pretty safe, right? Whereas you know, Bob's basement software, maybe we need to, you know, have a little more scrutiny. Open source, but if you step back just a little bit, that product selection process and vendor selection process applies equally as much to open source. Right? There's just, like you said, there's not the forcer of having to go through a purchasing process. So you or I just open up NuGet or NPM and woohoo, off we go, right? But yeah, as a responsible developer, you should be going to your you know, team lead, and they should, you know, escalate it up the chain, or however your organization is structured, and there should be a conscious choice to say, hey, I'm going to use this web grid, or yeah, whatever it might be that you're using. But I'll pick that one as a great example, because back in the VB days, so this would, you know, late 90s, I worked with a company as a consultant, but they had acquired a grid control and they used it everywhere in hundreds of forms, hundreds of pages. And that was in VB5, and the grid control vendor didn't make enough money to justify upgrading it to work in VB6. And so this poor company was stuck. They had no migration path off from VB5. And I actually don't know eventually what happened. I was brought in to help do an assessment and try to come up with a plan. And the assessment / plan was basically to find a VB6 grid that was somewhat similar. There wasn't one exactly the same. And then rework several hundred pages with complicated business logic. You know, it was horrible. It was horrible. And this wasn't even open source. This was a commercial package, right? But it's the same vulnerability.
Yeah, had it been open source, they maybe could have forked the source code and maybe looked it up themselves, perhaps, or something like that.
So, John, it gets even better because they actually did a decent vendor assessment, realized the vendor was not a big company, and they had paid for the company to put the software in escrow. So they had access to the source code.
Nice.
But they didn't have the money or resources to rewrite the control from the VB5 control model to the VB6 control model.
Yep.
They were in the same boat as their vendor, right? It would have costed several $1 million to get the grid control working in the new world.
And then the last on this same topic, it also goes to, as a developer, building in those abstraction layers when you're integrating with third parties, making it easier to swap out those third party tools that you're depending on. So if we are depending on something that's open source, can we make sure that that's something that we can easily swap out so that we're not tightly coupled everywhere?
Yeah, and sometimes obviously you can. But if you write your website using Angular or React,
Sure.
yeah, you're done.
Yep. You're not going to be abstracting that out.
So speaking of libraries and frameworks like that, you had mentioned CSLA, and I had some experience with CSLA 10 or 15 years ago. Is that still the same framework we're speaking of? I'm assuming there's been some major upgrades in the last few years.
there definitely have, and yes, it's still got the clunky 90s era acronym based name, but yeah, it depending on when you used it, because it existed in COM before .NET, and then I rewrote it for .NET, and the initial, both the initial COM version and the .NET version were somewhat of a framework and somewhat of a set of guidelines, right? It was kind of a combination. And people used it as a framework, even though that wasn't 100% my intent. But so somewhere around 2004, 2005, I embraced the idea that everybody's using it as a framework, so let's actually make it a framework. And that opened up a lot of doors. So a lot of people encountered it in the early 2000s when it was a nice basis on which to build your own stuff. And starting in 2005, a lot of the things that I had left for people to make choices or left for people to customize, I'm like, no. If it's going to be a framework, I'll be prescriptive. And so, you roll forward from that point through to today, and so some of the downsides are that it's less flexible, but a lot of the upsides are that it's a lot easier and a lot more powerful to use, because I've already, and I say but I mean, there's like 80 some people that have contributed over this time frame. So I should say we have, really made some choices about how we think things should work, and then created implementations or patterns that, make that easy. So it's been a fun journey.
Yeah, for those that may not be as familiar with CSLA, can you give just a brief overview?
Yeah, CSLA is an attempt to provide a framework that supports business logic as a first-class citizen. So there's a lot of UI frameworks, Angular, React, WPF, UWP. I don't know. There's tons and tons of them, right? And there's a lot of data access frameworks, Entity Framework and Dapper and JDBC and ODBC, and just tons and tons, Hibernate and NHibernate. But there are very few frameworks that exist in between the two to help you reliably and repeatably build and maintain your business logic. And in my view, personally, business software is a three-legged stool. You have to have a great user experience, you have to have a solid data story, and you got to have a great story around business logic, because that's just as important as the other two.
I thought you just put that in the UI and in the database.
Yeah, well, that's exactly what happens. That's exactly what happens. And then you wonder why it is that you can't ever move off from Windows Forms, which is, this isn't real recent, but it was at some point not that long ago. I was talking to one of the product managers at Microsoft, and they were like, "Yeah, Windows Forms projects are still like the second most open type of project out there or something." I mean,
whoa.
Yeah, and nobody talks about it, right? But they're all in maintenance, and there's just this massive reams and reams of code that and the framework hasn't substantively changed since 2005. So it's not like anybody needs to talk about it or ask questions on Stack Overflow, because it hasn't changed. But it also means it's like all that code, it explains why .NET 5 and .NET 6 now support Windows Forms in the new versions of .NET, and it's because there's I'm sure that a lot of that software is being run in some extremely large and influential corporations.
Yeah, on .NET 2.
Yep, exactly.
They're gonna have a fun time upgrading, let me tell you.
It's and yet the problem is exactly what John just said, because they almost certainly wrote all their business logic in Lost Focus and Click event handlers.
It's all about that rapid application development.
Totally. Yep. So CSLA is a direct opposite of that, a direct reaction that says, hey, let's actually formalize the idea of business logic, create a business logic, one or more business logic libraries that are logically and hopefully physically separated from the UI and from any sort of data access, so that as the UI technologies change over time, or as you decide to move from Entity Framework 5 to Entity Framework Core and realize that you're going to have to rewrite your whole data access layer, that you don't have to rewrite your whole business logic just because of a tech change.
So is it does it have any of the popular UI separation techniques that are around today, like any of the MV star patterns or CQRS or anything like that? How does it keep the business clean and separate from whatever UI somebody might be using?
Well, I kind of stumbled into what ultimately became called MVVM. It's the for me, part of the fun of watching this all unfold over time is that I've been doing this for long enough that I've seen some of my choices become design patterns. And so CSLA is based around the idea of creating domain objects, classes that encapsulate the shape of your data and also the business rules that apply to that data. And MVVM is kind of like that, sorta. But I was able to rely heavily on Microsoft's continued focus on data binding that has existed since 1993, if not earlier. And so the philosophy basically is that you use domain-driven design, object-oriented design to come up with a domain model that meets your use case or user scenario. You implement it using CSLAs so that your business logic is all set up as a set of rules that trigger when they're supposed to, and so on and so forth. And then you're able to bind that domain object or set of domain objects to your UI using whatever flavor of data binding is appropriate for your UI framework. So it's not exactly MVVM, but it's not entirely unlike MVVM either, right?
And looking at the updated documentation for CSLA as well, it looks like supported platforms for Docker and Kubernetes, WebAssembly via ASP.NET Blazor and the Uno platform, Windows, Mac, Linux, .NET Core, Razor Pages, MVC. I mean, it seems like every technology that a developer may have some knowledge of or experience with is listed here in the supported platforms, as well as important links right here on the main page.
Yeah, that's true. I don't want to take too much credit because an awful lot of it is that .NET paves the way, and then we follow, which is not to say that it's free, right? In that supporting all of these different platforms definitely requires some work within CSLA too. But Microsoft and the Mono project, Xamarin, have done a lot of the heavy lifting, and then we come along and smooth it over. But that is one of the value propositions of CSLA, is that if you have used CSLA to write your business layer, we do our best to abstract any differences between the runtimes that where .NET exists. And so it is really, really cool, because if you've got let's say an app server that's running in .NET framework on Windows, and you're like, oh man, I could save a couple cents an hour running on a Linux server in Azure, and but I'm running 100 app servers 24/7. That adds up to real money, right? To a large degree, you can recompile that app server, that .NET code into .NET 5, .NET 6, and compile it for Linux, and it'll just keep working because CSLA will mitigate some of the differences and so forth. And I'm all about the idea of running things in containers, and running it either in Kubernetes or an orchestrator that's just built into Azure or AWS, and then making CSLA really work well in those spaces. That I believe is a key part of I think that's going to become the dominant future for server-side computing.
Yeah, I'm always amazed at companies and organizations that have chosen Windows app services on Azure, when we can choose to run on a Linux app service plan for twice the performance at half the cost.
Yeah, well,
So are we looking? Is CSLA then one of these modern cloud native type applications, or what is the path forward there?
When I think about cloud native, in particular, I think a lot about if you go to a site called 12factor.net, so the digit 12factor.net, it's a website where they've collected a set of design patterns for being cloud native, and it's fantastic. And that's kind of like becoming, I believe, industry-wide the gold standard for, if you're going to say you're cloud native, that means that you're adhering to some subset or ideally all 12 of those factors. And so, CSLA over the last several years has evolved in key ways to support some of the. It already did some of the factors, and others not so well. And if you look at the progression of .NET from .NET Framework into .NET Core into .NET 5, it has followed that same progression. Not surprisingly, the folks at Microsoft are going, "Oh wow, these are great ideas that really do work." And so, if you take like the configuration subsystem in .NET, and the way it works today versus the way it worked with config files and everything, that change is 100% around the configuration pattern that is in the 12-factor document. And so CSLA also, of course, had to change its configuration pattern to fit the ideas that make it work really well in cloud native. And time well spent. I mean, because it opens up these doors for not just scaling or cost reduction, but for a whole new and way better developer and ops cycle, the DevOps process. 12-factor cloud native makes that almost infinitely easier in most regards.
Now, before we started recording, you said something about a connection between cloud native and Blazor, right?
I did.
Yeah, Blazor is something I am very interested in. I've been, well, except for work, I've been programming in that exclusively for the past couple of years. So what is that connection? What's fill me in?
Well, I think so cloud native is all backend server side, right? Containers, and Blazor sits on top of WebAssembly, which is uh, literally sits next to JavaScript in the browser. And instead of writing JavaScript, you can write WebAssembly, which of course you and I hopefully never will do. We'll have a compiler. We'll write C, C++, Rust, C Sharp, and let the compiler compile it to assembly. But nonetheless, these compilers, all the ones I just listed, compile to WebAssembly. So you're able to run native code in any modern browser. And so on one hand, these things don't look alike because it's a client side thing versus a server side thing. But where they are alike is that if you are writing cloud native container based server software, you really don't care about the operating system. You really, really don't, because that's part of the 12-factor model is you don't rely on the OS. And if you're writing your client software to run in WebAssembly, like in Blazor, you really don't care about the client operating system or even the browser. Right? Any modern browser, they all work fundamentally the same, and this stuff works on Android and Windows and Mac, and and so I've got this vision that I suspect is a very likely true vision for the not distant future, that most of us will write most of our server software to run in containers, and we'll write most of our client software to run in WebAssembly, and we won't care. As developers, it's immaterial whether our users are on a Windows machine or a Mac or a Linux desktop or a tablet, right? It doesn't matter a whole lot. And similarly on the server, once you write cloud native software, you don't really care if your container is a Windows container or a Linux container, or there's people working on WebAssembly containers. So maybe your backend starts running in WebAssembly too. So it starts to tickle the mind a little bit, right? It's like, I develop stuff in C Sharp, I compile it into a platform neutral environment that ends up being compiled for Linux, compiled for WebAssembly, compiled for Windows, and I'm happy everywhere.
Well, and I feel like we're actually that last part is actually kind of close, because I think I saw that somebody got Node running in WebAssembly in a browser. So they were actually serving the website that they were working on from within the browser, hosting it up to the browser so so that they could see the site they were working on, which is it's a bit tangled, but if you could get things like, I don't know, I guess they'd have to open up special ports or something, but if you could get things like Docker and Kubernetes running from a WebAssembly base, then, really, yeah, everything could compile to WebAssembly and then just go. And then it would just be a matter of optimizing the WebAssembly interpreter, which would be pretty
except
neat.
it's not an interpreter. WebAssembly JIT compiles and runs native.
Oh.
So it's the original prototypes for WebAssembly were interpreted, but WebAssembly today takes your binary bytecode and compiles it native. So whatever machine, whatever device it's running on, when it's actually executing, it's native code.
Okay, fantastic. I figured they were still doing the interpretation, because there's still some performance degradation between, like, uh, certain cases for, or at least there was a couple years ago. Maybe it's all changed, but for like if you were doing heavy computation, you could still do it faster with plain old JavaScript than you could with like Blazor and WebAssembly. Maybe the hangup was in Blazor, not in WebAssembly.
Well, certainly, yeah, the heavy computation is probably not true anymore because of the compilation. But where Blazor and pretty much all of the UI frameworks that exist across any language, WebAssembly currently doesn't directly talk to the DOM. And so you have to use JavaScript as an intermediary to go between your code and the DOM. And so there's a little, overhead that goes there. And hopefully at some point, a future version of WebAssembly will just let us directly talk to the DOM. And that should clinch it, right? Yeah. But in the meantime, we are in this kind of interesting world.
You're muted, or you're just moving your lips.
Yes. Is it better? Are there any... No. Oh, okay. I'll go back to mute. Are there any resources that you can direct our listeners to for folks who maybe are looking to get into CSLA or and see if that's something they want to use and how to kind of get that going, or maybe just trying to deal with open source?
CSLA is on GitHub. So you can just search for it there, but the easiest way is to go to cslanet.com. That's the homepage for it. In terms of just getting into open source, that's an interesting one. There's a lot of open source projects. In fact, I would say most are interested in people contributing. And of course, that might sound intimidating, but getting a high quality bug report is like gold. Trust me. Getting a one-liner, this doesn't work. Now that happens all the time, but that's not useful. But yeah, actually having somebody take the time to document what they were doing and what failed and how it failed, that is a phenomenal contribution all by itself. Only one-upped by people that actually dig into the code and come back and go, hey, I think if you change this code in a little, to this other code, this might work. And sometimes they're right and sometimes they're wrong, but just that amount of troubleshooting, is just. And then you get into folks that contribute docs or samples. Again, invaluable. And it is the rare. Like I said, there's only been, or it depends on how you look at it, 80 some people that have contributed to CSLA that have commits in the code base, right? Some of those are small, and some of them are like people that completely rewrote the serialization or completely replaced the largest chunks of reflection with link expressions. Just massive amounts of work. Johnny Beckham from Norway took the basic rules engine and enhanced the heck out of it because the company he was working for had very sophisticated business rules, and they were committed to using CSLA, so they kept extending the rules engine. So but that's not the bar, and I think that's kind of the key, right? Is that if you're in that spot, that is unbelievably awesome. But if all you can do, is file high quality bug reports or some troubleshooting outcomes, or get your employer to use GitHub sponsors or Patreon or whatever, to help have recurring funds, or look at different software projects, open source projects have different funding. Like I've mostly over the years, I've funded mine through the sale of books and videos. And, but other organizations have support contracts or rely heavily on consulting. And so, looking at the business model that's behind an open source project and trying to engage with it is probably the best way to support that project.
Very cool.
Excuse me. What has been helpful in your career that you might share with those just getting started or those looking to level up their own careers?
Patience, I think, is probably the key. Sometimes I count myself fortunate because I get to do what I love. Right. I love software development. I love design. I love programming. And so to me, this is all awesome. Sometimes it's actually work, even though I love it. Right. It's like, okay, I'm stuck building this thing on a technology that is already obsolete. But there's the point. What I mean by patience is that sometimes it's worth sticking around for a period of time and saying, maybe the tech isn't as trendy as possible or whatever it might be, but there's a lot to be learned about the software architecture or the way that the software and the business interact. Most software projects don't stand in isolation in that, the software, we're writing the software, but somebody else is retraining an entire 1,000-person workforce and maybe buying multi-millions of dollars worth of new machines on the shop floor, or right, we don't know, but you could know. And that's where I'm getting at, is that being patient, keeping your eyes open, and being focused on learning not just new software tricks, but how software applies to your end user. That's the road to becoming an architect. So, or a senior developer or whatever, but I mean, that's right. It's the road to progression in our industry.
Mm-hmm. So where can our listeners go to sort of follow you and keep up with what you're working on?
Mostly I hang out on Twitter. So I'm Rocky Lhotka on Twitter. I'm on LinkedIn, and I check that pretty often, but I'm not a huge poster in that space. And so, but you can go to Lhotka.net. That has all my contact information and links to my blog. I know blogging is apparently outdated, but I still do quite a bit of it. And so, yeah, between my blog and Twitter, that's pretty much where you can find me.
Well, all right, Rocky, really appreciate you taking time to speak with us today.
This was a lot of fun. I appreciate it. Thank you.
That was Rockford Lhotka. Rocky is an open source and distributed systems architect, author, and speaker. He's currently CTO at Cognizant Soft Vision and calls Eden Prairie, Minnesota home.
If you like this episode, no, wait, hold on. If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And catch us live each week on Twitch, and be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
I was so waiting for Ash to jump in and say something.
I was about 2 seconds. If you didn't, I was going to jump in there and be, I'm Clayton Hunt. So it wouldn't be the first time.
No, it wouldn't be the first time. So, Rocky, in the chat, I'm pasting a link, and that is the thing I was talking about with Node. It's they're calling it web containers, and it's from StackBlitz. And I already pasted it in the chat for anybody who's looking.
Yeah. Interesting. So what I was referencing, and I would have to search for it to find it, was something not unlike this, I think, in that except that it's a Docker container host that basically just directly hosts WebAssembly. So, and maybe they're related. I don't know if they do that using Node or if they're just direct. I don't think so though. I think they're it's a lighter weight, right? They're literally just compiling and running the WebAssembly code. But this is a container that runs in the browser, so this is interesting.
Yeah, it's a WebAssembly based container.
Sorry, we're still live on Twitch. Do you want to transition over, and we will raid our friend over at Mitch's workshop, who's working on some Python, struggling to figure out real-time Twitch event handling with Event Sub.
I was gonna let Surly let you do the drop, and you just, all right, fine. All right. Thanks,
Well, so
everybody. We will catch you later, I guess.
All right.
We're all distant this week, so
yeah, it's vacation week. So
good night.